Prudent Scholars in association with Goa Headmasters Association.
Hello students, myself Ramita Sarvesh Mopkar from Progress High School. We have dealt about metals and non-metals in part 1. So now let us move on to the part 2. In part 2, let us see about the occurrence of metals. We have seen different chemical properties, physical properties, different properties of ionic compounds of the metals and non-metals. Now where these metals and non-metals are present? They are very useful for us, but where do they occur? These metals and the non-metals, out of this we are going to study about the occurrence of the metals. Okay? So these metals which are there, they are found in the Earth's crust. So Earth's crust is the major source of this metal. So in the Earth's crust, inside the rocks, these metals are present in the form of minerals. So when these minerals they are present, or when the minerals are present in the Earth's crust in the natural form, or the metals which are present in the minerals or in the Earth's crust in the natural form, they are known as minerals. Okay. Now let us see about this mineral later, but before that, few metals they are also present in the sea water in the dissolved form. Dissolved form meaning they are dissolved as salts in the sea water. We have seen about the reactivity series. So the metals which were placed at the top of the reactivity series and at the middle of the reactivity series, these metals which are there, they are not present in the nature or in the Earth's crust in the free state. So they always occur in combined state. So they are combined with what? They are combined with oxygen, sulfur and carbonate. So we are having the metals in the combined states as sulfides, metal oxides, metal sulfides and as metal carbonates. Only the least reactive metals which are placed at the bottom, that is silver, gold, platinum, they are available or present in the Earth's crust in the free state. That means they are available directly as gold, silver and platinum. Now the metals which are occurring naturally in the Earth's crust, they are known as minerals. Now at some places what happens, the concentration of the mineral is very high. Some mineral, the metals which are present in the mineral, the concentration is very high, there is very high percentage, and we can extract also them in a profitable manner. Okay, we can make profit out of it, we can earn money by extracting such minerals. So such minerals which contain very high percentage of a particular metal and which can be extracted profitably, these minerals are known as ores. So here we have seen metals, I have spoken to you that metals are present in dissolved form as salts in seawater. Now out of all the metals and non-metals, aluminium is the metal which is present abundantly on the Earth's crust, and out of non-metal, oxygen is the non-metal which is found in abundance. Now we have spoken about this, that the less reactive metals they are found in free state. Less reactive meaning gold, silver, they are found in free state. Other metals they are always found in combined states. Now let us have a look at few examples of ore and metals, how they are present. So sodium is a metal. It is present in the form of a rock salt. Formula is NaCl. Aluminium, the ore of aluminium is known as bauxite. So here this last column, they are the ores, they are the names of the ores. Aluminium oxide, Al2O3.2H2O. 2H2O is the water of crystallization. Manganese, MnO2, the name of manganese ore is pyrolusite. Zinc, zinc is present in two forms. It is present as sulphide ore and carbonate ore. When it is sulphide ore, it is known as zinc blende. When it is carbonate ore, it is calamine. Iron, the ore of iron is hematite, present in oxide form Fe2O3. Copper, as copper glans. The formula is copper sulphide, Cu2S, S is sulphur. Mercury, the name of the ore of mercury is cinnabar, and the formula is Hg is the symbol for mercury and S is the sulphide which is attached. Okay, so we are having the formula as Hg. So these are the names of the few ores which are present in the earth's crust. The next, let us see now, we know that ores are present. Now how to get metals out of it? So this can be done only by extraction. So we need to extract the metals from the ores. Then only we will get the metal which we want. Now there are different steps involved in this extraction. The first step is enrichment of ores. Second is extracting metals which is depending on the reactivity. Reactivity means the reactivity series which we have seen in the earlier class. And third step is refining of the elements or the metals. First step, which is saying the enrichment of ores. Enrichment is nothing but removal of impurities. So when these ores are extracted, many impurities are present in the form of sand and soil. So that impurities are to be removed. Okay. So that process is known as enrichment of ore. Depending upon the metals, different techniques are used in order to enrich the metals. Now here, when the impurities I said they are present with the ore, these impurities they are known as gangue. So gangue is nothing but the impurities like sand and soil which is present in the ores. The next step, second step is extracting of metal. So we know that metals can be extracted only depending upon the reactivity. Now this process of extracting metal from its ore in the pure form is known as metallurgy. So metallurgy is the definition of the process. So what it says, process of extracting metals from its ore in its pure form. So when we get the metal from the ore in the pure form, the process is known as metallurgy. Now let us begin with the extraction process. The first we will extract the metals of low reactivity. Low reactivity we have seen silver, okay, copper, they are having very low reactivity. So when silver is seen here, that is we have taken example of copper and mercury. So copper, it exists as copper sulphide and mercury exists as cinnabar. So we will see when it is a sulphide ore, when any ore is present in sulphide form, the first step which is done is roasting followed by reduction. Roasting is what now? Roasting is nothing but heating of sulphide ore and converting into oxide in the presence of excess air. Air we mean to say air means oxygen. So here the sulphide ore is heated, in extra oxygen is being supplied to it and we are getting the formation of some kind of a oxide. So let us begin with the roasting of mercury ore, that is mercuric sulphide. The name of the ore is cinnabar. When it is heated, here triangle you can see, triangle means heating process is going on. So when it is heated in excess of oxygen, it is getting converted to mercuric oxide and sulfur dioxide, SO2 gas is released in the process. Now the second step after roasting will be reduction. Here we have got mercury in its oxide form. We want pure metal. Here this is not a pure metal, it is oxide of a metal. So if we want to remove this oxygen, we have studied in the earlier chapter, removal of oxygen means reduction. So, we want to remove this oxygen. So, how to remove that oxygen? Again it is heated, but now oxygen is not supplied. So, we are reducing it. So, when after reducing we will see the formation of mercury as the form of pure metal is obtained, and in this process oxygen gas is given out. Second example was of copper sulfide. So, copper sulfide, this is the ore of copper. When it is heated, because since it is a sulfide ore, again what we will do, which process we will do, roasting. So, roasting is done, we will get formation of copper oxide, and in this process again same sulfur dioxide gas will be given out. So, here since both the ores they are present in their sulfide form, we have to do the first step, that is roasting. Roasting means what? Heating. We are heating in excess of air. The second step after the formation of copper oxide is reduction. Now, here during this roasting process, full copper sulfide, that is the full ore, is not getting converted into copper oxide. Portion of this copper sulfide is left unreacted. So, what it will do? In the second step during reduction, the part which is left to react, it will react with the copper oxide. So, we will have a reaction like this, copper oxide plus copper sulfide. The reaction will take place in, and how the reaction is taking place? The reaction is taking place due to heating. So, these two compounds they are heated, we will get the formation of copper and sulfur dioxide gas will be given out. So, here copper which is having oxygen, it is getting reduced. So, oxygen is being removed. Removed means reduction. We are removing oxygen. So, reduction is taking place in this process. So, always students remember extracting metals, when the metals they or the extracting metals from their ores. So, when the ores they are the sulfide ores, we have to always perform roasting. After roasting we will get the desired metal in its oxide form. So, we want to remove that oxygen. So, we will perform a reduction process and we will get the pure desired metal which we want. Next is extracting the metals in the middle of the reactivity series. So, in the middle we have manganese, zinc, iron. So, let us deal with the first metal, that is zinc. So, zinc it is present in two forms, that is the ore is present in two forms. The first ore is the sulfide ore and also it is present as carbonate ore. So, here what is done, the zinc sulfide ore, since it is a sulfide ore, what we will do? We will do roasting. So, roasting means it is we are heating the ore in the presence of excess air. So, when excess air is supplied, we will get the formation of oxide. So, zinc oxide will be formed, sulfur dioxide gas will be evolved in the process. Now, we will take a break for reduction. Now, let us move on to the carbonate ore. So, we cannot do roasting. Here zinc carbonate means ample of oxygen is present with zinc carbonate. So, what has to be done? We do not do roasting, we will not supply air, but what we will do? We will heat this ore, but in absence of air. Here air is not supplied to this carbonate ore. So, what will happen here when it is heated? This product is getting transformed into zinc oxide and carbon dioxide. So, one reactant is splitting into two products. So, here this is which reaction, which type of reaction? It is decomposition reaction. So, zinc carbonate is getting decomposed to zinc oxide and carbon dioxide. Now, here we have got the metal in their oxide form. So, what we can do? We have to reduce it. So, reduction can be done. So, zinc oxide. So, in this process of reduction, carbon is used as a reducing agent. So, zinc oxide when it reacts with carbon, it is heated and we will get formation of zinc and carbon monoxide gas will be given out. This reaction is a type of displacement reaction. Carbon is more reactive than zinc. So, it will displace the zinc from this oxide and carbon monoxide we will form, and we will get the formation of pure zinc. The next metal we will see is manganese. Manganese is present in the earth's crust as pyrolusite, that is manganese oxide. So, there is no roasting and calcination. We do not need to do this roasting and calcination. So, directly we can heat it. So, now heat or reduce it. Reduce with what? Can we use carbon again here in this process? No, we cannot use carbon as a reducing agent for manganese oxide. The reason is manganese is more reactive than carbon. So, if we use carbon as a reducing agent, no reaction will take place, as we have seen in the case of copper sulphate and iron sulphate. In iron sulphate we had put copper wire, but there was no reaction. Same thing occurs here. Manganese oxide, when it reacts with carbon, no reaction will take place, because manganese is more reactive. Carbon will not displace manganese, but here what happens? Zinc is less reactive. So, carbon can easily displace zinc from its oxide. So, here displacement reaction is taking place, and in calcination zinc carbonate is converted to two products. So, the main reactant is getting decomposed. So, decomposition reaction is occurring. Now, the next we will see the use of reducing agent. We are not using carbon. So, now next which reducing agent to use? Any other metal which is highly reactive than manganese can be used as a reducing agent, and the displacement reaction can occur. So, here aluminium is used. So, manganese oxide, aluminium is used in the powder form. When it is added to oxygen, when it is heated, we get the manganese metal in a pure form, plus aluminium will combine with oxygen to form oxide, and large amount of heat is evolved in this process. And because of this liberation of high amount of heat, the metal which is obtained, it is getting melted. Such reaction is known as a thermite reaction. Thermite reaction is a reaction in which the metal which is obtained in molten form. Now, let us take the definition of thermite reaction. Reaction in which aluminium powder, here we are using aluminium powder, is used to reduce a metal oxide to metal. The metal oxide is getting reduced to metal, and this aluminium, which is a reducing agent, is getting oxidized to aluminium oxide. So, it is also we can say this reaction is redox reaction. Reduction, oxidation, both things are taking place in one reaction. Now, the remaining part let me read. And metal is extracted in molten state due to liberation of heat. So, this is the thermite reaction. So, this reaction of aluminium can, if it reacts with iron oxide in this manner, we have seen the ore of iron has to be, if we want to extract iron from its ore, it has to be reduced first with the aluminium. So, aluminium again is used in the powder form, we are getting iron in the molten state. So, this iron which is obtained in the molten form is very useful if there are cracks in any machineries or any instruments or any railway tracks. If the railway cracks in the railway tracks, they are being joined with the help of this molten iron. So, this reaction, that is this thermite reaction of aluminium and iron, is very important, because it is used to join the railway tracks or any cracked machineries. And the reaction, since it is evolving, large amount of heat or lot amount of heat is liberated in this process, this reaction is highly exothermic, and because of the large amount of heat which is liberated, the metal here and here, they are getting melted, and we get the metals in the molten form. The next is extracting highly reactive metals. So, we know the highly reactive metals, they are potassium, sodium. So, this potassium and sodium which are highly reactive, we cannot use carbon as the reducing agent. If the metals they are present in the oxide form, we cannot use carbon as a reducing agent. It is because the carbon, because the oxygen is having high affinity towards the metal. So, oxygen will not be displaced with the help of a carbon. So, now what is being done? So, the next technique in order to obtain the metals, the highly reactive metal, is electrolysis or electrolytic reduction. So, what is electrolysis? Electro, we will split the word into two. Electro means electric current and lysis is breaking. So, breaking in the presence of electricity is electrolytic. Now, what to break? So, here in the electrolysis what is done, we are taking electrolyte and that electrolyte will be any molten chloride of the desired metal we want to extract. So, here we have taken a container or a beaker, we can say, we have added a electrolyte. Suppose if I want to extract sodium from the ore. So, what I will take? I will take the solution molten chloride as sodium chloride. So, sodium chloride is the electrolyte which is being added here in this container. If sodium chloride is the electrolyte, what do you mean by electrolyte? Electrolyte is a solution which helps to conduct electricity. So, through which the electric current easily flows, they are the electrolytes, because in electrolytes free ions are present. As soon as electric current will pass, the solution will get dissociated into ions which will help the electric current to flow. So, we are having two electrodes, one is cathode, one is anode. So, when electric current is passed, here you can see the battery or electric cell is connected. When the circuit is complete, the electric current will flow through the circuit. The sodium chloride now we have taken, it will get dissociated into Na plus and Cl minus. What the Na plus will do at cathode, Na plus will take one electron and it will deposit on the cathode. Why only on the cathode? Because it is Na plus, positive ion, and cathode is negative electrode. So, opposite charges will get attracted. So, sodium will deposit on the cathode. So, by this process easily we can obtain sodium in a pure form. And what about the chlorine which is present in the electrolyte? So, chlorine which is present as ion in the solution, it will gain the electrons, okay, and it will liberated as chlorine gas here. Chlorine we all know, chloride ion which is formed in the sodium chloride electrolyte. So, what the chloride ion will do? It will not gain, it will lose the electrolyte electron which it has taken. So, it will lose that electron and it will be liberated at anode as chlorine gas. So, this way we have got or we have extracted sodium metal. Similarly, we can also extract magnesium, potassium. The next step is refining of the metals. Now, we have extracted all the metals of low reactivity, high reactivity, medium reactivity. Now, the metals which are extracted, they may not be in pure form. There may be some impurities present. Now, we have to remove these impurities. So, after extraction, the metals contain some impurities. So, how to remove these impurities? The impurities can be removed by electrolytic refining. So, electrolytic refining technique can be used to remove the impurities from the metals, from the extracted metals. So, many metals such as copper, zinc, nickel, silver, gold, they can be refined in this manner by electrolytic refining. Now, here in this electrolytic refining, let us see what is done. Let us have a look at the picture. So, this is a picture of electrolytic refining. We are using electrolyte. Suppose now if I want to refine copper. So, if I want to refine copper, so I will use copper sulphate solution. So, it is electrolytic refining of copper we are doing. So, I am using copper sulphate solution. There are two electrodes. One is cathode, one is anode. Anode means positively charged electrode, cathode is negatively charged electrode. Both they are connected to a battery. Okay. They are connected to a battery or an electric cell, combination of electric cell, it is known as a battery. So, when the circuit is complete, what will happen? Current will start flowing. When current will flow in the circuit, the copper sulphate solution, which is a electrolyte, it will get dissociated. Dissociated into what? Copper ions and sulphate ions, SO4 minus 2 and Cu plus 2. These are the two ions which are formed in copper sulphate. So, what this copper ion will do? Copper ion will gain the 2 electron which has lost, and it will start depositing here, you can see on this electrode, that is on cathode. Here anode is the strip of impure copper, cathode is a strip of pure copper. So, obviously all the copper will start depositing on pure copper from the solution. Now, this impure copper means copper strip is having copper also, along with that there are many impurities. So, the copper which is present in this impure copper electrode, it will dissolve in the solution. So, when it dissolves in the solution, it will get converted into copper plus 2 ion. Then these ions which are dissolved here, they will again go and stick on the surface of the pure copper, that is surface of the cathode. So, this way all the copper metal which is present in this anode, it will dissolve in the solution and it will deposit in the on the cathode electrode, that is the pure copper strip. So, this way in this process what will happen, the size of this anode will decrease, because all the copper metal is getting dissolved in the solution, it is depositing on the cathode. So, anode size of the anode will decrease, the plate will become thinner, but on contrary the pure copper, that is which is deposited at cathode, it will make the second strip of pure copper very thick. So, more copper is going on depositing on this cathode. So, this way this cathode is having fully pure form of copper metal. So, this is the process of electrolytic refining of copper. Okay, so, what we have seen in, so coppers can be electrolytically refined. So, many metals such as copper, not only copper, zinc, nickel, silver and gold can be refined by this method. Now, we have seen that impure metal was taken as anode and the pure metal was taken as cathode. Now, the pure metal, that is copper, which was present at the anode, it was dissolving in the electrolyte and it was depositing on the cathode. Then the soluble impurities which were there, we have said it is impure copper, means there was impurities. The impurities which were soluble in copper sulphate, they dissolved in copper sulphate, but the other impurities which were not soluble in the solution, they remained at the bottom. So, they remained at the bottom of the anode here, they settled down here and they were called as anode mud. So, the impurities which are settling at the bottom of the anode, they were known as anode mud. Now, next concept we will deal with is corrosion. So, all the metals, they are getting corroded, rusted. So, here we are having the three pictures. The first picture is of iron article. So, we can see a brown flaky substance is being formed on the surface of this article. So, it has got rusted. So, when it is getting rusted, when it is getting exposed to air, water. Here we can see the corrosion of silver. Silver, the color you can see here. but when it gets corroded the color turns to black. So, here the silver article is getting corroded. In this example we can see a copper plate, we can see a deposition of green layer. So, that green layer is nothing but it is a rust or a corrosion which is occurring in the case of copper. Okay, so, these are the problems which are faced by few metals. Now, it is seen here silver articles they are becoming black in color. So, how they become black? Silver it combines with the sulfur and we are getting formation of silver sulfide which is black in color. So, copper when it reacts, when the copper utensil, we all know in our surrounding carbon dioxide gas is present and plus oxygen also is present. When copper reacts with oxygen it just forms a black coating, but when the same copper it reacts with carbon dioxide a green coat is formed. Okay? You must have seen the utensils at your home which is made up of copper. After some days if they are left untouched, what will happen? They will react with carbon dioxide which is present in the nature and they will form copper carbonate which is a green color powder which is being formed on the green colored layer which is formed on the surface of the copper. Next is iron articles, a flaky brown substance is being formed on the iron articles which is called as rust. Now, how to prevent corrosion? Which are the different steps which are involved in the process and how to for the prevention of corrosion. So, corrosion can be prevented by painting, oiling, we can also apply grease or by galvanizing, anodizing or making alloys. So, making alloys is widely used technique in order to prevent corrosion. So, what the alloys do? When we make alloys, the properties of the pure metal are changing. It can be improved also. Now, the properties of any metal is changed when it is mixed with some other substance. Okay? An alloy. Now, what is an alloy? So, alloy means what? It is a homogeneous mixture. So, two metals or one metal or non-metal they are added in equal proportion, okay, in order to get a new compound, and that new compound is known as alloys. Now, the electrical conductivity and the melting point in the case of alloy is little less as compared to that of the pure metal. Now, here we have the picture, the first one is the brass, second is bronze. So, these two pictures they are the alloys of copper. Okay, in order to prevent corrosion we are making alloys and these are the alloys of copper, this is the brass and this is bronze. Here we can see the utensils which are made up of stainless steel. Stainless steel is also one kind of a alloy. Here you can see one person with a machine pen like structure in the hand, that is the soldering machine. So, this soldering machine is used in order to join two wires or for welding purpose. Okay, the soldering machine is used. Now, what is this soldering, what is present in that, let us see. So, here the electrical conductivity we said of an alloy it always changes. Now, the first alloy that is the stainless steel. We cannot use iron directly to make articles because it stretches easily. So, first iron is combined with carbon in order to make it hard. Then we can add to it nickel and chromium in equal proportion in order to obtain stainless steel. So, stainless steel is an alloy of iron, nickel and chromium. The next one is the alloy of mercury, that if one metal is mercury then the name of the alloy is amalgam. The next is brass. Brass is an alloy, we have seen the picture, it is alloy I said, it is an alloy of copper, but along with copper there is one more metal which is added, that is zinc, and to bronze we are adding tin. So brass and bronze, they are the two alloys of copper. But we have seen copper is very good conductor of electricity, but brass and bronze, they are not good conductors of electricity. Now second is, we have seen the soldering machine which the person was using to weld or join two wires. So here what is that soldering thing done? So it is nothing but it is an alloy which is made up of lead and tin. So the two metals are added in equal proportion in order to get solder, and it is having, since it is having very low melting point, okay, it can be used for welding purpose of the wires. Now we all are wearing gold ornaments. The gold which we wear, it is not pure gold. Pure gold is having 24 carat, but the gold which we wear is having 22 carat gold. So why it is so? Because the pure gold is very soft, it can bend easily. So what is done to the gold? We are adding copper or silver. Silver is added or copper can be added in equal, not in equal proportion. We said 24 carat gold. So 22 parts of gold is added and 2 parts of copper or silver can be added. So therefore it will make the gold very strong enough in order to convert it into jewelries. So pure gold is very soft, so we are not using the gold of 24 carat. So now the last part we are doing here, the question answer round. Now what are minerals? So we have seen the elements or compounds which occur naturally in the earth's crust, they are known as minerals. What is gangue? We have seen the impurities such as sand, soil which are present in the ores, they are known as gangue. What are ores? So when minerals contain a very high percentage, I said very high percentage of some kind of metal at one place, then such minerals, they are called as ore. All ores are minerals, but all minerals may not be said as ores. Name the ore of mercury. It is cinnabar. The formula is HgS. What is roasting? Roasting is what? The definition says it is heating of the sulphide ore in the presence of excess air, okay, is known as roasting. What is calcination? The carbonate ores, here it is nothing but we are heating ore, but it is heating of carbonate ore in the presence or absence, in the absence of air, or we are supplying or we are heating strongly in the limited air. So this process is calcination. Now how are metal oxide reduced to the corresponding metal? So we are using reducing agents like carbon, and by displacement reaction the reaction takes place. The zinc oxide is reduced to zinc by using a reducing agent. Name the reducing agent used. It is carbon. Next, we have written one formula there. MnO2, one equation is written, plus Al, 4Al, we get manganese plus aluminum oxide plus heat is liberated. So name the type of reaction. The type of reaction is displacement reaction. Name the metal used as reducing agent. It is aluminum powder. Name the metal getting reduced. It is manganese. So here we can say it is also displacement reaction. It is also oxidation reduction, that is redox reaction. Plus if you want to say, we can also call it as thermite reaction. So there are many answers for the first question, that is identify the type of reaction. Plus heat is evolved, we can also say exothermic reaction. So what is thermite reaction? It is the reaction of iron oxide with aluminum powder which is used to join the railway tracks or the cracked machine parts. Plus a large amount of heat is liberated in this process, which makes the metal obtained in molten form. So how are metals higher up in the reactivity series obtained from their compounds? They are obtained by electrolytic reduction or electrolysis. So, name the electrode where metal deposits are found. Metal deposits are found at cathode, because the metals, they are present in ion form as cation, and cathode is negatively charged, so opposite attracts. Name the electrode where chlorine gas is liberated. Chlorine gas always is liberated at anode. Name the method used for refining impure metals. Electrolytic refining. So, what is anode mud? The insoluble impurities that settle down at the bottom of the anode, they are known as anode mud. Next is, what is rust? The brown flaky substance which is formed on the surface of the iron when it is exposed to moist air. It is known as rust. So, name the different methods used to prevent iron from rusting. So, we can say painting, galvanizing, making alloys, greasing, oiling. So, all these methods can be written. So, why iron is not used in pure state? Because iron stretches easily, so we cannot use. So, name the component which makes iron hard and strong. So, it is carbon. What is an alloy? It is the homogeneous mixture of two or more metals, or a metal and a non-metal. What is solder used? Solder, since it is having very low melting point, it is used for welding electrical wires together. So, name the acid that does not react with most of the metals. It is nitric acid, because it is oxidizing hydrogen to water. So, we have finished with the questions. Thank you, students. So, we have finished with the second part of the chapter. In this, we have covered with the occurrence of the metals. We have seen minerals, ores, okay, different properties of ores, different types of ores we have seen, how to extract. So, basically there are 3 steps in extraction, that is enrichment, then extraction depending upon the reactivity, and third is refining of the metals. So, when we extract the metal in the pure form, that process is known as metallurgy.